I would say let's hardcode our symbols, right? Let's make a little function that can print out all the entries in the table. Oh, we don't even need to have a function for this, I just realized. We can just do this ourselves, right? Okay, so we make sure lookup still works. What we then do is size t I equals 0. I is smaller than table, table dots, and we just go through the whole capacity because we don't know how these slots are distributed, right? Um, then we just say table entries, and we can just iterate over them. And let's fish out the entries. So GBA symbol T. Let's do this as a pointer. And then we just say symbol what do we do? Name length. So if symbol name length equals 0, then this slot is empty. So we want to look for something that's not empty. And then we just print out what actual value we have in there. So let's start by the index. Then we have the name. We have the hash. Hash, and we have the type. No, we don't need the type because the type will always be the same. So name, hash, I suppose name length. Let's just do it this way. Yeah. And that's it. So, and then we can print exactly these things out. So we have the index, which is I. We have symbol. We have the name. We have the name length. And we have the hash. There we go. Now you can see because it simply prints out the whole buffer. You can see like there's like a bunch of garbage in here because we're just using up too much space for all these strings. I really need to like change this. Maybe using malloc is fine. I don't know. Hang on, the symbols are all in the file anyways. I can use just chop. Okay, yeah, no, okay. I know what to do for next time, but that's okay. Anyways, so we can copy all of these. And we kind of see the distribution between those in the table, which is quite nice. And we can actually try and see where the collisions are if we so choose. But I thought at this size we don't have any. I mean, let's just look at the last few digits. No. Ah. Nope. Nope. Almost, but nope. Okay. I mean, we cannot look this way, really, right? hang on, we set the table size to the right size right here. So if we do this, no, this collision count doesn't do anything anymore. This is nonsense. If this ever happens, there seems to be something seriously wrong, right? No, so okay, let's make another loop. All these items. And just try and see if we can get if table entries y dot hash equals symbol hash, but only if y is not I. Puts collision dude. Cool. Okay. Hang on. Did I do this the right thing? So y is 0. And then if y is not the same as I, and table entries y dot hash is the same as symbols hash. Okay. Does that make sense? Hang on, but only okay. Only if we have one of these. And we need to skip table entries with name length of 0. Okay, now we can do collisions. Puts collision dude. Cool, no collisions. Excellent. Okay, so I wanted to copy these, put them in Sublime. That's just easier to deal with because now we can do selection. Nope. Nope. Okay. Oh, I see what I did. Find, quick find all. Okay, so now do this. Okay, this is where we add the entries and hard code them into our list. So what we would do is say entries number 1 equals, and then we would say this dot name name length hash. Okay, and then we have to add type, which would be GBA symbol type. Whoa. Symbol type operation. Okay. Copy this, and I don't know, where do we plug this in? So this obviously works only on the initial table, but I don't want to put it into the init symbol table, right? What we can do is just say bool GBA init default symbol table. Symbol table T of table, and then we can say, well, if not GBA init symbol table, then return false, right? But if that worked, then what we want to do is say GBA symbol T entries equals table entries, and then bam. Okay. What's wrong here? GBA symbol T. Do I have to do it this way? No. Can you not initialize a struct like this? Well, that's all C++. I don't give a shit about C++. There's also more assignment. Oh, is what? I have to do it this way. Does that just work with GBA symbol F, whatever? So that works. That's a bit annoying. Not gonna lie. Okay, well, I guess what we can do is just add them all normally. Then I don't need this output anymore though. So yeah, we can just do that. So just have this, right? Basically copy these and say, okay, we have const char const values. Let's call them operations, GBA known operations. Operations symbols. Okay, and then GBA add operation symbols into the table. Whoa. So we're not going to do the initialization. Instead, what we're doing is we're just iterating over the operations. Does this still work? Right. Return true. So if I do this, will that still do the correct thing? Let's figure it out. So instead of calling that, actually, instead of doing all of this, call GBA add operation symbols into this table. Okay. Count is 88. Yeah, okay. So this still works. Excellent. Cool. So we can just do the fill in here. So for size t I equals 0, plus, and then we just say GBA insert symbol by name, and we insert it into the table. The name will be GBA operation symbols. And strlen operation symbols. And GBA symbol type operation. Okay. If this fails, we have to stop what we're doing. Okay, cool. So now we can kind of get rid of this test stuff right here, right? We no longer need to run any tests with these things. I mean, we do, but in the broader context, right? So after reading the whole file, we want to start tokenizing it, but right before we're tokenizing it, we should initialize our symbols table. So init symbols table, and that will be just GBA symbol table, GBA init symbol table. Capacity, what do we say? Let's call this symbol table size. I think roughly it was roughly 40 bytes or something, right? 32 for the chars and then like all the other stuff. I don't know, it's 42, so nicer number. If anyone gets the reference. Okay, so symbol table size, table. If this fails, so let's see, how can this fail? Well, it can fail mostly on Windows operations, right? So if this fail, what we probably want to do is say print print Windows error, fail to allocate symbols table. And then we should go to table cleanup. What is this cleanup doing? This is buffer. Buffer cleanup. This goes to buffer cleanup. This goes to buffer cleanup. This goes to table cleanup, which will be a new thing right here that we call table cleanup. And then we say GBA free symbol table, and that will be our symbol table. Cool. So now even if we finish normally, we clean up the table. Okay. Actually, no, we don't need to go to table cleanup right here because it, initialization failed, right? So we still need to go to buffer cleanup, but with the next failure we need to go to, and the next thing will be GBA add operation symbols, and the operations we can do are defined in the header, so we don't need to worry about this. How can this fail? Well, the only way this can fail is by GBA insert symbol by name. If that fails, and that can fail for various reasons, right? It could either fail for the expanding the symbols table, or via mem copy. But we won't be worrying about exactly why it failed. We're just gonna say failed to initialize symbols table with known operations. Yeah, and the stream will be stdr. Cool. And then we go to table cleanup. Or did I name this? Yeah, table cleanup. Let's call it symbol cleanup. So this is how we initialize our symbols table. And now we can just start processing. So we have our token right here. Yeah, this is where the copies already bite me in the ass because I need to do a string copy even though it's not strictly necessary. Oh, this is annoying. I really want to change this now. I'm sorry. I'm sorry. I'm quickly gonna do that. So 256 is fine. Right. And then what this is a pointer to an unsigned data structure. Okay. Mem compare name. Yeah, this is still the same. This is still fine. This just works. We have the entries in its symbol table. Yeah, still the same thing. We're just allocating pointers, which is fine. Then we have this one. I forgot to access the right. Okay. strnlen really? No, I didn't do this. This is known code, right? This is my code, so fuck it. Okay, then we have the table here. Yeah, this is also still fine. Nothing has changed with the hash computation, except we can make this const. That is fine. Insert symbol. That is certainly also still fine. We still have name length, entries, stuff like that. Then symbol name equals, which we already determined is fine because we do a mem compare, right? Yep, and then we just copy the symbol struct. Grow symbol table, also quite okay. Okay, then we have lookup symbol name. Yeah. I mean, we do a mem compare, which is fine. Okay. And then insert is the stuff that is worrying. So we have a name, and then we just point to that name. We no longer need the mem copy. What we do is name and just do this. Now, could that be a problem? I don't think it is, because we're reading the whole file, we're keeping it in memory the whole time, so we're just referencing someone that is in memory already. And things like the operation symbols right here, those are allocated in program memory as well. So that should just work. I mean, those names don't disappear on us, is what I'm trying to say. So, okay. So anyways, we're getting the tokens from line. And now, how deep do we want to go with this token processing? So, specifically, when we have a word, we could either just return word, or we can try to make sense out of it right here. So, for example, is this an operation? Or is this a user-defined symbol? Which is probably okay. Or we just return words, like it is a word token, and we try to make sense of it on the outside. I think I do not want to pass the symbol tables around to the tokenizer, right? So let's take care of all of this stuff outside. So instead of word, let's call it what it is. It is a symbol, but we don't know what kind of symbol yet. Right? So this will be symbol. And then so we have our tokens, then we're trying to process the tokens and process tokens, tokenized line by line, correct. We have a token, iterate through the token, we'd get that first token right here, and if token type is symbol, Mm. Actually, we need to put more structure into that instead of just iterating over this. So, but how? It feels like this needs to be in a separate function as well, so I can just return out of it on specific failure modes and other things like that, right? So let's do that. Let's make this its own function right up here. Void, and just call this GBA process token. Why did I name this with underscores and everything else not? This is so inconsistent. Hang on, let me fix this because this is gonna annoy me now that I saw it. Rename. Print Windows error. Okay, apply. Cool. Okay. Now, process tokens. Okay. What are we getting? We have a token buffer, so we could probably do something like tokens max tokens if token count is 0, then we have reached the maximum amount of tokens per line. Oh yeah, because there will be at least one end of file or a new line. So one of these regardless. Okay. Okay, so then we can do size t I equals 0 is smaller than max tokens. Yeah, it's going alright. Currently trying to process tokens. Finished the hash map implementation. So for the symbols table, which with 312 lines, not too bad. So yeah. Anyways, yeah. So we're iterating through the tokens, and if tokens I type, so we're gonna switch over the types, and then we have token types. So if this is end of file or it is a new line, then we just return, because there's nothing left for us to do. If there is a white space, well, we just ignore it. because if we start a line with white space, why bother, right? And we can also terminate early if it is a comment, because if it is a comment, we know there's nothing else to do as well. So now if we have white space, we switch to the next token, or we simply jump out of here. But if it is symbol, then process symbol, right? This is where we start processing our little symbol. Sorry, just been trying to figure out how to do this. Okay. I guess the first thing we'd like to well, no, there is no first thing whatsoever. We need the start of the value, so symbol name right here. And it starts right on the input buffer. That means we need a reference to the input buffer. So that would be a GBA buffer T buffer. Let's call this input. Oh my god. Okay. Input. Now, input has data attached to it. And the tokens I.start is the starting location of the symbol name in the block of memory that we read out of the file. Then we have symbol length, which simply is tokens I.end minus tokens I.start. Because this is the absolute end position in the block of memory, and we just want to calculate the length, so we just take end, subtract the start, and we get the length. Voila. So we have the symbol length. So what we then can do is have GBA symbol table T symbols. And now we kind of realize, right, we could maybe make like a superstruct where we have the buffer attached to it, the symbols attached to it, and the tokens attached to it, right? So we can just pass that around as the context. So, but for now, let's just construct it this way. So now symbols, and well, we have convenience functions for these, right? So what we can do is GBA get, oh, I was looking on the wrong thing. There we go. Look up some symbol by name. And where do we need to look? Well, we need to look in our symbols table, and we are looking for symbol name. And we are looking for symbol length. And this either works or doesn't. what we're getting back is GBA symbol T. Symbol. Cool. If symbol is null, I'm writing deal with unrecognized symbols here because, well, there might be something special that we want to do if a symbol is not recognized at some future point. I need to kind of think about this a bit more, but at the moment let's just print an error. So what do? We do f puts ws, and we say unknown symbol %s. We could be nice and kind of have lines in there, right? But that would mean we need to pass a line number in here. Again, showing that we could kind of make this a little bit nicer. Size T line. Unknown symbol S inline %LLU. Okay, so the symbol is symbol name, and then we have the line. But so this is std error, right? Wait, what? Is that not how we do? Oh, I want W print F. I'm an idiot. Okay. WF print F. No? This is wrong anyways. FW print F. So we also want this on this one. std error, right? Because we want to do output to the standard error, not the normal output stream. Okay. So let's do this. Unknown symbol S inline this. Okay, and we can say return. And we can make this a bool and actually say return false if this is the case, right? And these are just return true. I mean, technically, probably don't need to worry about this because max tokens, but let's just do return true anyways, whatever, doesn't matter. Yeah. Okay, so if we cannot find that symbol, then we're printing out the symbol. Now, here's the problem. This will print out the whole file. So let's say this is unknown, right? And then we have a bunch of other text right here in different lines, right? Whatever, doesn't matter what we do here. So, unknown. So we're processing line by line, and oh, I actually had text up here. Nice. Processing line by line. And if a symbol is unknown, we're trying to print it out. But because our memory location is actually the whole file, it would just print from that location onwards to, like, you know, all the way down there. So if I run this, well, I should also be calling it, right? What is this? Tokens, token count, 1 minus. Okay, yeah, that's the offset we're setting it to. That's fine. GBA process tokens. Well, we have our input buffer. Pointer to the input buffer. We have our pointer to the symbol table. We have our pointer to the tokens. We have token count as the max tokens. And we have the current line of text. Now, for that, we just make a counter. Line equals 1. And then just pass this in. And then in the end, we do line plus plus. Okay. So, and there you go. Unknown symbol. And then, oh, will you look at that? Look what we're printing out. A whole freaking file. In line 9. Well, great. What do you mean line 9? Oh, right, okay. Yeah, so the printout gets shorter and shorter as we advance in the line. I forgot, hang on, let me make this more clear for you. So like this, right? So the file gets shorter and shorter as we advance the lines because there's only like a little bit left for all of these things, right? So anyways. So probably what we would like to do is limit this somehow. Now, can you limit string outputs? So we have S. There's no augmentations. No, there is. Precision specifies the maximum number of word characters to be written. Or is that for the calling of this? Hang on, what is this? In, so this is UTF-8. Okay, and then it prints out the individual characters. Okay. Okay. What's the max symbol size that I chose? So let's do this, and then we're calling this one right here. What do I need? I do need string age, I believe. Do I? Nope. Is it your W chart? Yep. Okay, so anon symbol. From the source, which will be symbol name. Size in bytes would be symbol length. MB state. Why do I need the state? Sure, have a state, why not? And then this. Really? You need to do a set? Okay. Interesting. Right. Why do you still copy all of it though? Oh my god. Okay. What am I not getting here? Destination buffer is that one. Then we have the symbol name and the size in bytes. Ah, because fucking hell. I just shifted the problem essentially. Annoying. But why though? Shouldn't it be null terminated in the end? Does that do anything? No. Okay, so I just wanted to figure out a way to take those UTF-8 characters, basically transform them into a wide char representation, so UTF-16, and then print them out like so. So we can say unknown symbol, and then just basically have the symbol name in there. In line da 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 is wrong, right? And for some reason, it only has the first characters and then displays all the other shit right here. So why is that? Wait, is this just per character? It is. Oh my lord. Okay. Now the state actually makes more sense. Why I need a state, right? Right. Okay. Yada yada yada. Okay. Unrecognized symbols. So what we would have is U8 start is symbol name, and then UA end is symbol name plus symbol length. Actually, no, let's not do it this way. For symbol length plus, and then we call this thing with unknown symbol address of unknown symbol I, and then symbol name I, also the address of that one, please, and then size in bytes. Oh no, I see. Right, because it can be bigger than that. No, that will be symbol length minus I. That's still okay. And then we pass in the state, but we return something, and what we're returning is how many characters we actually transformed, right? Converted, and if converted is bigger than 0, then I is this. Okay, what am I not getting? You converted 1 byte, so that would be the U. I see. Converted. Nope. I is plus converted. I'm not sure if I need to add an old character, but let's just do it. Okay. Okay, I get that part right, but I is 7, symbol length is 7. Okay, so I specifically probably need to set this. Yes! Oh my god. What a painful thing to do. Okay, so finally managed to have our symbol name converted into a white character string, so we can put it into the white character output of this thing. And then we can say on which line these things appear as well. And let's see, unknown is unknown on line 1. Blah, 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 blah. Okay, it doesn't, that's cool, because this semicolon here starts a comment, right? So the name ends right here, which is correct. Then we have unknown symbol on this one, line 3, 4, 5, 6, 7, until line 9. Excellent. Will you look at that? Okay. So now, but there's a few no names already, like such as LD, push, or add, or whatever. Or actually, let's make it SBC. So those are all no names. And for now, interesting. Huh. Well, that is a good start. Why? Add operation symbols. And we add all the operation symbols. No, we do not. Because I have a coding error in here, ladies and gentlemen. There we go. So these symbols are now known, which means we actually find them. What do I have here? Line plus plus. Yeah, so this line stuff is ugly. I really want to have a token struct at some point that we just can, sorry, not a token, brain, work, name, what am I looking for? A context struct that I can pass around, which has the whole state of the parser or the assembler in it. So if we have the context, we can just basically just access everything and ask like, okay, which state is the parser in? What is the output? What is the input? Where's that buffer? And that kind of thing. So this probably should be like a little convenience method as well. Not gonna do that now though. Actually, we can make one real quick. Void convert UTF UTF-8 to 16. Yeah, why not? We have wchar_t, which is our source. Nope. Our destination. We have a size t, which is destination size. We have our u8 source, and we have our source length. Okay, and that means we can take this stuff, maybe not the buffer, because this is the arrow buffer, right? So like this, and then get all of this. Yeah. So converter, we probably don't need that. We can just do it this way. Converted becomes I plus equals this. Symbol length will be the source length, right? size ti can stay here, that is fine, and that will be destination I. Converted, no longer a thing. Symbol name will just simply be source length, and unknown symbol will be destination. Okay, but then just bool is fine. Okay, and then if no, this needs to go in before. So if the source length is larger than destination size, actually we want source length plus 1 because we need to fit in the null termination character in the worst case. So if this is the case, then we can't simply do anything. This cannot wrap around because it's an unsigned, so that is fine to do. If this works, it works. Okay. Yeah, should be fine. And then we can use this up here. Cool. So our source is unknown symbol. Sorry, the destination, unknown symbol. Destination size is max symbol name plus 1. The source is symbol name, and symbol length is the source length. Cool. And this doesn't work. Then unknown symbol is just an empty string. Let's test this again with like a really unknown symbol. La, 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 la. Test. Cool. La, and test. Okay, so this still works. Excellent. Okay, but if it works, we have to see what kind of symbol we're having. And this is at the beginning of the line, right? So what are we expecting to have in the beginning of the line? Well, the only thing we're really expecting is to have an operation. Like there's nothing else for now. We're not gonna have labels or anything like that yet. All we want to do is like be able to recognize any of these different commands and do something with them, right? So let's check for operations. So if let's do do we want to do a switch in a switch? It's kind of a bit rough, isn't it? Right. Actually, this can go in here. Okay. So now we can do a switch and a switch. Why not? So if the symbol we're having is of type symbol type operation, then do magic. If it is anything other than an operation, then it's something that we're not expecting there. So, to do print a good error message, because at this stage we only want to see an operation. At the moment, we can just say puts yo, invalid, put an operation dog, there we go. It's the kind of error message the user wants to see, right? Okay, so how would that work? Let's say, well, we have a temporary one word, right? So we can quickly just add a random word into our table. TBA insert symbol by name, and we're gonna add this to our symbol table. Let's say okay, right? 1, 2, 3, 4. And the symbol type is just word. Cool, so let's add this. And now if we have okay in our file, that should print an error. And probably what we want is to return false here, because this is like a terminating result. Okay. And indeed. So now we can put operations that are known at the beginning of the line, which is exactly what we want. I mean, we can test this with white space as well now, right? We can test something following immediately with a comment, if we so choose, something with a bit more white space. Yeah, this is the thing that we need to do next. So after we have an operation, we should, we do not expect anything else afterwards. So we need to check for this kind of stuff. But at the moment, let's just do that. And yes, indeed. So this just works. Okay. So now that we have an operation, we can actually start processing it. So to do process operation. What does processing an operation mean? Well, it means checking what kind of operation we're having. Well, how would we do that? Oh, we know what kind of operation we're having. It's the symbol name, right? We just need to attach a little bit more information to our operations. I'm just trying to think how to do this. Because what we probably need now is like, okay, we have parsed the text. We know it is a symbol of some kind, and we know that the symbol is an operation. But now we need information of what kind of operation, right? And we can probably have just a switch in here with like an operation type number, which should be quite fast because switch statement and the compiler usually just makes this a lookup table for us. And it's just comparing numbers really, instead of strings. So yeah, we can do that. I haven't thought about attaching extra information onto the symbols though. So this is a bit rough. So what kind of information do we need? We need to know, let's make a list, what kind of operation is it? What kind of arguments are expected / valid? No, that doesn't need to be attached because we can figure it out based on the type. Okay. I think what we should probably do is some kind of union. There's something in here. I have not used unions before, but basically if this would be a symbol type of operation, we have an operation type enum in there. Otherwise, if it is anything else, a user-defined symbol could have information such as, is this, well, where has the symbol been defined, like on which line, or which byte in memory, and such things. So probably, okay. How do I use unions in C? Let's see. I actually have the, wait, I thought I had the PDF open. Oh, I do. There we go. Union. Well, this will take ages. Okay, language. Concepts. Nope. Expressions. Wouldn't be an expression, would it? No. Interesting. Okay, so we can have just an nominous union. And so union would be either one of these that is valid. Uh, so how you have to imagine this is, it basically is, a union is a block of memory that is always the same size, and the size is determined. So let's say you can have, I don't know, you can have a char, or you can have an int, right? So a char is 8-bit, an int is 32 bits. Now, only one of this can be set at a time. So you can either set s to a value, or you can set x to a valid value, right? Not quite, but anyways. But everything needs to be a known size in C, right? For it to work. Like, everything has a known size. It occupies a certain amount of space in memory. So what a union does is, it has a block of memory in here, and it is based on the largest type that you specify here. So this would always consume 32 bits, because the largest element in here is 32 bits. So we have 32 bits. So even if you set a char, right, you only have 8 bits that are occupied with data. In reality, it still has 32 bits. So, and as I said, the reason we want this is because we want to attach different kinds of data on different symbols, right? So a simple type operation, just for example, needs a simple enum that specifies what kind of operation, right? Who are you? And let's say a word, for example, would have like, okay, on which line in the source code did I specify this word, or something like that. I don't know yet, but we'll see, right? So now the annoying part, however, is it makes this a lot more complicated, right? Especially the GBA insert symbol by name. Because now I suddenly need to attach a lot more information onto all of this than I actually wanted to. So maybe the whole type should be a struct, so like symbol data, and then have a union in there. So, okay, maybe let's do that. So something like type def struct GBA symbol info struct. Right? Then we can have a GBA symbol info here, which we just call info. And we move the type into this struct. And now we can have a union in here. That is whatever. And for this, let's create. Well, let's leave this empty for now. It doesn't matter. But what we need is we need to do type like this, and then we it's no longer type. Sorry, what it is info. Info. I'm just going through these things to see if there's anything I missed, but I think this should be okay. So then essentially how you have to think about this is like, this is just basically the struct which is a key value pair, right, for our entry in the symbols table. The key is the name and the hash, and the info is the value, the actual value we want to attach to that specific key. And depending on what kind of value we're having different data structures that we can access. Cool. So I guess we start with I guess we can just chuck this into symbols here since we already have all of these here. But we also kind of need to adjust this array a little bit, which will be annoying. Okay, let's do this like this, and go over to Sublime Text because it will be a bit easier to edit over here. Whoa. No, how do I do this again? I thought that's what I was doing. Control Shift L. Ah, there we go. Okay. So we can name this GBA. I noticed just now that the name GBA was a bit a misfortune to select because that could stand for Game Boy Advance, but that's not what it is. It means Game Boy Assembler. Game Boy Assembler. Sorry, Game Boy. What the hell? Okay, GBA operation type LD. Right. Oops. Okay, whatever. Let's just do. We don't need the lowercase in this instance, so let's just get painfully rid of those. Actually, we should have done that as well while we edit. radius. Okay, let's just focus on these lines. Okay, so those are all our operation types. Yep. So that can become our enum. So type div enum GBA operation type. Okay. So we can have operation. Is a union of one acceptable? And then I just don't need to set it or something? I don't know. Let's try it out. What can go wrong, right? So, but now we need to set the operation type for this one as well. We kind of need to attach that, right? That information, which will be annoying. How do we do this? Actually, is there a to lower? STD to lower. There we go. We can do character by character to lower. I don't want to do that though. Why not? Okay, and what we can have is U8 name. U8 alternative, and then GBA operation type. Cool, and then we can do this. Okay, and then we can initialize it like so. GBA op operation type LD. Okay. Push. Whoops. Pop. LDHL. Nope, not what I wanted to do. ABC. Sub. Right. SBC. No, man, come on. And my fat fingers. XOR, oh dear. CP. Well, the good thing is we only have to do this once, right? Inc. What am I doing? It's right here. RCA. Then we have RRA. RLC. Real life. Cool. RC. Dear Lord, how many? Ah, fuck my life. Okay. RR. Nope. Again. Shit. SLA. SRA. Cool. SRL. Swap. Bit. Set. Come on, I can do this. Set. This probably is a faster way to do this, but whatever. T. Nope. I agree. Nope. This is freaking tedious. CCF. Okay. But we're almost done. SCF. Cool. DI. Right. EI. Whoa. Hold. Yes, please. Hold. Please hold. And finally, stop. Cool. Oh my god. That was way too tedious. So we have this now, and then when we say add operation symbols, well, we now have symbol info, so what we can do is say info and then access this, right? And then we can do I need a pointer? Nah. No, I should. And then insert by name. So we have name, string length of info name. So, and these, we have GBA symbol info, so we need to build GBA symbol info out of that. Symbol info T. Let's just call it OP info and sim info. OP info. I forgot what is in symbol info already. Jeez. It's the type. The type will be GBA symbol type operation. And then we have an operation which will be info. Nope, it is OP info type. Well, that's not confusing at all, is it? But whatever, it's just the first initialization, right? And then we just copy sim info into here. Correct? I think so. So now it's not symbol type, but rather symbol info type. Okay, what did I do wrong? Okay, we added a test symbol right here, but I mean, we don't really need that anymore. Let's just chuck that away. Access violation, that's a good start. So hang on. Same type qualifier used more than once. GBI insert symbol by name undefined. Well, you'd be correct to assume that. Oh dear, my stomach. Initializing different const qualifiers. What do you mean by that? Hang on, let me rebuild. Different const qualifiers. Because you are a const U8 name. I mean, we can do that as well. That should be fine. Again, initializing different const qualifiers. Oh, is that because this needs to be const as well? No, because I made the other thing const. Okay. Function GBA token differs levels of indirection. Right, you'd be correct. Then we have how can you look at the code? I mean, you look at the monitor and you see the code. I don't understand. Okay. Okay, that worked, but we still have an access violation. Okay, so call stack, what do we do? It's because we're doing something funky here. What are we doing? OP info name equals null. Why would that be the case? Okay, let's see. Windows debugger, we have a count of 133, 132. Wait, why? Because I'm calculating the bytes wrong, you doofus. It's one of these now. Aye. Good gracious. Okay. There we go. Wait, did that work? Oh, right. I had a bunch of stuff in here, so... Unknown symbol SBC. Well, this is concerning because SBC is definitely in here, right? So SBC. SBC. Why are you unknown? LD and add seem to be working, but SBC is just... Oh, of course, right. Because we've only inserted the main name, but not the alternative name, which is the lowercase. So alternative, alternative. Cool. There we go. Fantastic. Okay. So now we have a bit more information about our operation that we're using. And so we can access that right here, right? Now let's see. We have a symbol. Cool. We look up that symbol. And if that symbol is anything but an operation, we return this ridiculous error message that we need to change at some point. But now that we know it is an operation, we should probably have something like bool GBA process operation. Okay. Return process operation. Now, why return? Well, because process operation now handles the rest of the file. So anything that's left after the operation is an error anyways. So what do we need to process information? Well, we probably need we need the symbol info, that's for sure. So GBA symbol info t info, and it's lowercase GBA. And then we have a switch over info, and we know this is an operation, so we just switch over the operation, and then we can have all, you know, this stuff. This shebang right here. Right. And say case this brick. Can an invalid token type ever happen? No, I can't. It's our code, right? These are not dynamic. Whatever. Let's just not worry about that too much. Okay. Yeah, and now we can just basically act on the operations that we want to. The simplest operations would be the ones without arguments, right? And there's a bunch of them available that do not need any arguments. And I think it would be good to just start with those. because those translate directly into just a bytecode essentially for the CPU, right? Let me check in the programming manual. Which operations do not need any arguments. I kind of like to start with the simplest ones. I can tell you right now that the LD operation is the most complex one. This will be... That one will be freaking annoying to do. Right? Like, really annoying. So let's just focus on the ones that we can just knock out, you know, straight away. But now we kind of need something where we write into the output, right? We need to have a file to write to. So this is where it starts to get a bit more cluttered, and now we can do something to actually reduce the cluttering a little bit. And let's start with the context struct that I mentioned before, right? So let's have a typedef struct, GBA context struct, GBA context T. So this is our parser assembler context that we can pass around, which will have all the necessary information available. And what is the necessary information? Well, we have a buffer, which is the input buffer, right? So we probably should carry that one around here. So this will be input. And then, because I already know that we need that, we're going to have an output buffer. Might as well just attach that. Cool. Then, well, we have a symbols table. We need to access it probably from many different places as well, or it would be rather convenient to do so. So we can just attach that as well. Symbols. Excellent. Now, what else? Well, we have tokens for one specific line. Why not carry that with us as well? I mean, and it has a fixed size as well, might as well. And instead of that, it is line tokens, right? Because it is the tokens for one specific line. Now, what line are we on? Well, we can specify that here as well with line. I mean, this line information here is probably just used for error messages. We don't need that anywhere else. Another thing we could do now, at some point at least, is imagine having something like errors, right? Because at the moment, when we encounter errors, we just stop parsing and like, okay, you would have to fix the error on that line, and then it continues, and then you would account another error, right? Until you like go through one by one. It would be nice if we just fail on one line, but just then continue. Why not? And then just, you know, spit out all the errors that we encountered for every line immediately without stopping parsing. I mean, that's kind of what we're doing if we just go to print onto standard error, we would just have to like adjust these returns here. Yeah, I think, okay, so this makes no sense. Sorry, we're just using standard stream already, so we do not need to keep track of the errors like that. Never mind. And that's it, I believe. Okay. So now we can try and use that. So in our main, where we have the first input buffer, what we're doing is let's get our context, right? And then instead of input buffer, right, we call GBA init buffer, which is fine, called input file size with that particular alignment. And we're passing in the context. Excuse me. What do you mean you don't have the buffer? Dude, what the hell? Arrow type. Okay, I don't know why it's complaining about the type right now, but let's just pretend that we're using the context as the input buffer, right? So this would be context, input point data. Then we have context input capacity. And then we have context input size. Context input size. Context input is the buffer. And then here also context input. And then we're freeing the input buffer. Okay. Right, that's okay. Let's just fall through for now. Is this boy complained? Really? So if I now look for input, you will just magically work. Context in, no. Okay, I'm not sure what state Visual Studio is stuck in again. Let's just try restarting it real quick because this is annoying. Why it doesn't recognize my input buffer and stuff. Oh, I closed main C. Okay, context. And now it has it. Well, one of those Visual Studio things, I suppose. Okay, well, we initialized the context and used the context input buffer now instead everywhere. So now we can do the same thing with the symbols table. So instead of having a symbols table, I'm gonna have context symbols. Context symbols. symbols. And here we're freeing context symbols. Okay, and we have a little memory leak down here because instead of exit failure, what we should have said is go to symbol cleanup. Okay. So we have symbols and input. The things left are output, line tokens, and the line. And let's do line tokens and line now. So instead of line like this, what we will have is context line equals 1. And then we have passed in here context.line and increment context.line. Cool. The line tokens are stored somewhere else, so let's do that. So instead of tokens, it will be context.line tokens. And then here also context.line tokens. And then here context.line tokens. Cool. So this error message still works, but we're not terminating the process of this right now, right? So it's not an error at the moment. Like we're not doing anything with the return because this is just a prototype function right now anyways. But we can do that. Okay. Let's create the output buffer now. So the output buffer is a bit curious because every GameBoy ROM has a fixed size. And we kind of need to specify what size of ROM we want to output. I don't want this to be kind of dynamic in any way. So what I would like is in this file at some point to have something like this and then say ROM size, and then you can, you know, just select what kind of ROM size you would like. If you don't specify anything, it will default to 32 kilobytes. So let's make the default for now. Process, no. Or should this be a command line argument instead of the code file? But then that's kind of shit as well, right? Or should I just go with the maximum output size? Like the maximum ROM size, which would be, what was it again? 4 megs, I think. Let's look at the GB header extractor. We have the GB header right here. 8 megabytes. I mean, nothing really stopping us from doing that. And then just trim in the end. No, I kind of like. I feel like there should be header information available at the top of the project, right? So at the top of the file. I want to specify like, okay, ROM size, RAM size. I want to specify the title. I want to specify maker code, right? Just make a header. Well, logo bytes. This will be the Nintendo logo. What else? Did I miss something? Pack type, all this kind of stuff. So these should be defined at the beginning of the file. Just simply because it will determine a few things for the output in the end, for the ROM output. And it will also, you know, set the right ROM header, I guess. I mean, that is setting the output. Sorry, lost my train of thought. Didn't know what I was talking about here. But I mean, I also feel like it's quite nice as an introduction to like the file. You know, you open the assembly file and you immediately know for what project it is because you have all this information right here. I will not have any includes yet or anything like that, right? So there won't be something like this where you can then specify a different ASM file. And if anything, it should be coming after this as well. This should be the first thing that's always going to be processed. I feel like. I might change my mind on that, but let's do 32 gib for now for the output file. Allocate output buffer. So we have GBA init buffer. We have the size is 32 times. No. Right? Let's just do it directly. Why not? Will you look at that? Okay, 32 gibs. Alignment size. Well, this. And the buffer will be context output. And this is also print Windows Ender. Fail to allocate output buffer. Right. Oh, we're doing this. Right, that should happen before we even open the file for now. So let's move the context further up. So fail to do that, and if you fail to do that, then we can just say exit failure. We do not need to worry about any sort of cleanup, but what we need to do here is GBA free buffer No. See, now we kind of have a problem on our head. What if I do this? Right. What is the state of the context? Input data is null. Null. Okay, everything is null. Cool. So let's make a GBA free context, and then we can say we have context and we want to free that one. And we can say if context input is not null, then GBA free buffer context input. Oh, input dot data. Do not care about the result right now. Context input data, just for good measure. Then if context input, no, output data is not null, GBA free buffer, and we want the context output buffer. Okay, context output data equals null. I mean, really, this should be the case, right? We're invalidating the pointer or buffer free, so I don't need to do that. And then what else do we have? We have context symbols entries. Is not null. Then GBA free symbol table. Table would be context symbols. And then same here. Table entries should probably be null. And context line tokens, we don't need to do anything because that's just an array of a fixed size. Okay. So down here now, we can simplify our code a lot by just saying free context, actually result equals exit result, no, success. Sorry. Clean up. But this time it's just the context. So we have the context, we initialize it. No, actually, let's move this further down. So we have the input file. We initialize the input buffer. And if that doesn't work, then, you know, here we close the input file. And we go to clean up right here. Okay. Okay, now we can allocate the output buffer. And if this fails, go to clean up. Okay. In its symbols table, allocate symbols table. If we reach the maximum amount of tokens, should we go to cleanup or should we just try and read the next line? No, because we don't know where the line ends. This is terminal. Okay, fine. And then we go to process tokens. Okay, and this goes to cleanup, and that will free that stuff. Okay. Now I can simplify this a little bit, right? We don't need this, this, or this. Do we need max tokens? There we go. Size T, token count. And that should be done with context dot token count. We can have current token in there if we so choose. So once we start processing the token, we can actually follow that as well and pass it throughout, so we can access specific information of the token, specifically where it starts and ends. This might be useful if we want to... is it useful? No, not really. Okay, let's just... I mean, no, it is actually useful. Let's leave that in. Okay, so all of this shebang can now just be GBA context. Bam. And because we start, we should probably say current token equals 0. And then this becomes context current token context token count. Tokens, token count, token index. Let's phrase it this way. Right. Okay. Token index. Token index is smaller than token count. Then context token index plus plus. Context tokens context token index. So turn, break, and turn here. So, and this becomes context input data, context tokens, context token index. What we should probably do is say GBA token T pointer to the current token. So that would be context tokens context token index. And then we can say current token dot start, current token dot end, current token dot start. Except instead of dot, we need the arrows because this is a pointer. Fantastic. Symbols become context symbols. This becomes context line. Okay. And now we can process the information. So sorry, the operation. So we still need the GBA symbol info. There's no way around that, right? Because we already fetched the current symbol. so might as well just pass it in. And then we just pass the context. Okay. What I need is output offset, right? Because we need to start writing at a very specific point in the output buffer. And that is gonna be when we allocate the output buffer. We have context, output offset, and that should be after the header file. And I have this little GB header program that we wrote in previous streams, and there is header end, which is at this position. So this will be our offset, right? This is where officially the GameBoy program starts and we want to start writing data. Everything else will be just zeros. Well, not in this case, which I should rectify. Shit. This is where reusing the buffer was probably a bad idea. Trying to be too generic here. Heap 0 memory, that's what it was. Okay, eventually I have to look into this, but let's just do this. We zero out the memory, just make sure it's all done. For file reading, that's not necessary. Maybe I should specify like a different flag or something. You know what? Let's call it init buffer 0. Right. And then we also don't need the alignment size. Just have capacity. Process heap, buffer capacity, yep. Cool. And then I can call that in main instead. Okay, no alignment size, because that's not necessary for the output buffer. Okay. Why is this wrong? Oh, it's just tokens. Ah, damn. Okay, yeah. And this is just context now. Yeah. Okay, finally. Let's select a few operations that have no arguments, right? So DEA is one of them. This one, DAA. And what this is doing it simply should use, let's have a little convenience variable here. Let's just say U8 output is gonna be the context output data. Right, and then we can say output context output offset, and we increment it after we put the byte in there, because it's just a single byte that we need to put in there. And since C doesn't allow me to do, like, you know, byte syntax, which would be really nice, some languages allow that, so you can just write the bytes like this. I have to use my trusty calculator and do it like so. Because in the GameBoy programming manual, they just display the bits. So 1, 1, 1, followed by 0, 0, 1, and then 0, 0. Okay, so this is going to be hex 27, right? And then we can also do the same with CPL, which translates to, hang on, I'm just gonna copy this. Actually, CPL, this also happens for no up. This happens for CCF and SCF. Okay. And SCF. CCF, SCF. It happens to DI and EI. And it happens to halt. And to stop as well. Stop also seems to be writing a no up. At least according to this manual. Okay. Then we have the same for ret and ret I. Where are you guys? Ret and ret I. Cool. I will change the codes in a second, right? I just want to find all of the ones that I need. Everything else seems to have arguments. Swap SRL, yeah. Yeah. There's a few like RRA. Okay. RRA, RRCA, RLA, okay, and RLCA. Cool. I'm sure there's loads more. Hang on. So then we have ink, add, decrements, yada, yada, yada. Okay. No, they all pretty much require arguments after that. I know there was one jump that was kind of interesting because it can work with an argument and without. Ah, red. Okay, yeah, the return. So this is not quite correct. Argument is optional. So we need to look into that one a bit more carefully, I guess. Okay, let's write the values. So stop is 0, 0, 0, 1, followed by rest zeros. 1, 2, 3, 4. Yes, correct. So that is hex 10. That would be stop. It also writes a no-op though, so let's just do that. A no-op is 0, 0. I think, where's the no-op here, by the way? There we go. We can just say 0x0, 0. That will be a no-op. Okay. Then we have halt. Halt is 0, 1, 1, 1, 0, 1, 1, 0. So hex 7, 6. Then we have EI, which is 1, 1, 1, 1, 0, 11. Sorry, 0, 1, 1, not 11. That is hex FB. Yeah. Okay. DI 1, 1, 1, 1, and then 0, 0, 1, 1. SCF. Forgot which one of these I did. I think DAA, right? 0, 0, 1, 1, 0, 1, 1, 1. CCF 0, 0, and the rest is ones. So 0x3F. We have no up, yeah, which is 0, 0, 0. CPL would be 0, 0, 1, 0, 1, 1, 1, 1. So 2F. Wait, did I not do CCF? Oh, did I fuck up? It was bound to happen eventually. I should probably Stop. Okay, CPL 00 101 111. So that was the 2F, right? And DAA DAA we said is 27, right? But let's just verify this. 001 00111. Yeah, okay, that is 27. Okay, return I. So this is 11 011 001 D9. Okay. Sorry, I just had to check if these was one of the special bit shifting ones, but they are not. So these just have a single code as well. So RLCA, that is all zeros except the last 3, which is 7. And then we have RLA, which is this one set to 1 as well, so 0x17. Then we have RRCA, which is all of these. That is F. And then we have RRA, which is this. Right? 1, 2, 3, 4, 5. Cool. 1F. Okay. So as painful as this seemed to be, this is essentially how you generate the byte output, right? And we can actually now do that by, let's make a really hacky code. I mean, this is all pretty hacky. I want to factor this out a little bit later on, but once we're actually done processing, what we can do is just dump, you know, everything into an output file. Let's just use the same path. Why not? Is it WF open? Something like this. Yeah. So we're just using the same path, but we call this TB for the ROM, right? Call this output. And the mode will be write binary. S, because we want the file stream, so output file, right? So we have file, output file, and we pass that in. say like, oh no. Okay, and then we can say fwrite else fwrite, and what we want is the source buffer, which in this way is context output data. The element is size of U8, and the count is context output well, opacity. Size doesn't play a role in this at all. So, okay, and then we have the file, which is output file. And we just fclose output file, whatever. Not that we have to, because like once you go out of main, it closes this file eventually anyways. I'm not bothering with Windows here, but like to do write output file way nicer than this shit. Okay, so now what we can do is we could remove all this and just write a file with the operations we know now that produce an output, right? So this is our assembly file, and let's say we have, let's start from the top actually. So we have RLCA, done. We have RRCA, done. Our next operation would be RRA. No, RRA, thank you very much, autocorrect. RLA, sorry. RLCA. RLA. RRCA and RRA. Oh my god, these names. I can't wait to have like aliases for these. Okay, we have return I. Then we have DAA. We have CPL. We have NOP, CCF, SCF, DI, EI, EI. Jesus, I hate autocorrect so much. Why would you autocorrect this shit? Whatever, okay. Halt and stop. Is this everything? We know that. DAA, CPL, NOP, CCF, SCF, DI, EI, halt, stop. And because we want to see, because everything is zeroed out, that it actually does something, that it, for stop, that it writes no up as well afterwards, let's just make another DI afterwards, why not? Just for good measure. Okay, so imagine this being an assembly file where we have all these instructions that we use. And let's see what kind of output it actually generates. So let's fire this up. Okay. Because we have no break, right? Okay, let's try that again. Okay, cool. And let's check our output file. So we have, what is the folder again? Sublime GameBoy assembly. Okay, so Sublime GameBoy assembly. So here we have our assembly file, and here we have our output ROM. And as you can see, it already has 32 kilobytes, sorry, because that's how big the ROM is supposed to be, right? And if we now open this little thing in a hex editor, so we know that from position 100 to 104F, there's supposed to be a Game Boy ROM header. At the moment, there's nothing because we simply don't write it. But after that, the stream of bytes is essentially just instructions for the CPU to execute. And as you can see, we have written a few instructions right here. So let's just compare if these are actually correct. So we started with, so we went from top to bottom. So, and indeed we have 07, 17, 0F, 1F. We're going further to D9, 27, 2F, 00 for no op. We have 3F, 37, F3, FB, 76, and then we have stop, which is 10 followed by 00, and then we wrote another DI in the end, which is F3. Our first ROM. Ship it. Those were the simple operations. The other ones are way more complicated than that to implement because they have to deal with arguments, right? I think the first thing I will be looking at next time is the next thing I will be looking at is arguments that operations that only require one argument. So for example, such as red, which requires an optional argument, and then just some other things like probably all the bit shifting stuff and things like that. They only require one argument. This also will involve that we now need to pass arguments, which can be, either symbols, numbers, or other specially defined symbols such as register names or things like that. So that is cool. I like this. We have set a really good foundation for stuff. As you can see, it gets more and more complicated, but this is essentially it. Once we have down to pass arguments, there's nothing more to it. What we want is probably to replace this with some other writing method. So to have some byte writing that checks the final size of the ROM, right? That is because if we, let's say, we have a super long assembly file that fills up all 32 kilobits of the ROM, and then we write another instruction because we're like, oh yeah, I need to get this in, but we're at the end of the ROM, we should no longer be able to write into it, basically. Right now there's no checks for this whatsoever, so if we write at the end, so let's say we're right here, right, and we want to write one after that, well, our ROM ends, so this shouldn't be possible. But yeah. Okay. There's some other funky things going on later on when we have all these jump instructions, because those need to be able to jump and index into specific parts of the ROM, right? Because you want to jump into specific locations in memory. That is usually resolved via labels. That's why I went through this whole pain of including a symbols table and being able to add, your symbols and stuff like that, because that will come huge into play later on. Okay, that's about it. That was a long one today. My clock is ticking in at 7 hours, so I'm gonna stop for sure. but I hope you got something out of this at least. Anyways, because someone asked today in the stream how they can look at the code, I have to think about what to do there. I do not want to share code prematurely while this is still being developed on. So I have to think about what to do there. Eventually, I do want to share it, or at least the final tool. So we'll see. See how it goes. Okay, well, thank you. Bye.